I'll try to get some time with my presentation, but please bear with me. We are just a little bit late. So this presentation is providing details of the work done by my master's students, Douglas Yamashita de Moura, Brazilian Air Force officer. He unfortunately was not able to come, but I will be presenting on his and my behalf. So our domain of our investigation was focused on assembly task. And assembly task is only one part, but very important part of much larger maintenance tasks. And maintenance tasks is incredibly important in both civilian and military domain. The special emphasis that we wanted to take is training of assembly task, but for large number of people. You have masses of people that need to acquire that type of skills. Our studies typically include actual users, we call them end users, domain users, the scenarios that really work for in their domain. We observe constraints of their domain and also needs for their domain. And so what's typical for this type of situation for quite some time now is that we enjoy having robust, low-cost, commercial off-the-shelf devices that we love now, and they're certainly used in a number of domains, and training domain is absolutely enamored to have them and use them. And so we wanted to investigate if we could use that type of devices, commercial off-the-shelf, low cost, to address needs of this community. So ultimate goal in training communities is to train a large number of people, train them to much higher skill levels, so not only beginners and intermediate levels, but really aim for expert levels. Do it with as little time as possible, with less cost, and of course, they would like to have a skill retention rate being really, really high. So it's a lofty goal. When you think about that in many ways, that also means that people will be exposed to VR stimuli for a longer period of time. Their sessions will be longer, number of sessions, and so chances to experience cybersickness increase. The other need in this domain is also to be able to have those systems and use them for self-guided training and self-study. So not only that you will go to training center, but you will be able to do it yourself in your own room. And the same system being used for a number of, to acquisition of number skills is very good. One of our students coined the term gym bag training solution, which is really kind of metaphor for a very compact, lightweight, size-wise also small solution that you can take and have at your disposal 24/7. So you can train anytime, anywhere. And so it is certainly a goal of training domain. This is not to say that we can train everything in that manner, but number of skills can. And so when we think about virtual reality and an assembly task, I think that we intuitively have good guesses, why you would do that. Sometimes those systems are not available. You are talking about future systems. So VR is really the only choice that you have. Those systems, if they would like to train on the job, those systems may not be available. They may be in some type of environmental conditions that are prohibitive for humans to approach. But I would like to bring your attention to the last one. And last one talks about using VR training even when the cost everything the same. You may want to do it in VR because VR provides you with very easy collection, objective data, system-reported data sets. And so you provide instructors with a new tool that they can detect some trends, bad behaviors, and correct them as quickly as possible. Things that you cannot do with traditional types of training. So we should not forget that value of VR in training. Our research was informed by several streams of research effort, and obviously the first one was training of maintenance and assembly tasks in industrial setups, including transfer of training. And we derived good suggestions there. The number one is obviously stereoscopic immersive is definitely has to be considered with some guidelines on what to do and not to do in training system. human factor research in interaction techniques on assembly task, judgment of distance. And remember that here we talk about distances that are within arm's reach, so not too far. And so there was identified issue with compression of dimensions, but not of large magnitude. Interestingly enough, compression of dimensions was not found in augmented reality, only found in virtual reality. And of course, as we said, our interest is large-scale adoption, and so we wanted to address some issues flagged in the type of research. So our method is your typical method that you have for scientific inquiry and running of user studies. We identify research objectives and our global study consideration, and then went the top down. We ran quite a few pilot studies to refine all elements of the final study design, inevitable IRB documentation, running study, collecting data, and so on. So for study design, as we said, immersive stereoscopic was absolute number one. But we really wanted to push the boundary when the training centers are concerned and address their needs and test if non-immersive, non-stereoscopic, kind of the other end of that would be also a viable option. And why that would be important? We also already mentioned cybersickness, so extended exposure to immersive VR and stereoscopic VR is known to produce more severe symptoms. Well, the other one is, or the other two are, you have masses of people. And so masses, some of them will be apprehensive of using VR altogether, headsets altogether. One thing that we didn't talk about, but it's there, is hygiene, and having hundreds of people on a daily basis going on and on. You may not want to have headsets for a long time, and so if you didn't have to use it, we wanted to see if that would be an option. So we generated 4 experimental conditions. Some of our pilot studies dealt with choice of hand controllers. In our case, choice was to use Oculus headsets, Oculus Touch controllers, because they provided a grip that was resembled much closer to the grip that you have while holding physical objects. And a point to research community, having one set of controllers is just not enough. You will have a number of tasks that cannot be satisfied to a good level with only this type of controller. So as a research community, we should push to get plethora of input devices serving the same headset, if you will. Another choice was to go for non-immersive display solution. We tried Z-Space. Z-Space provides you just with interaction with pen and one hand, and we were interested in Bimanual. And so that was, and also holding hand quite high was really tiring. So again, we decided to go for 3D ready TV with shutter glasses and track IR, which worked really well. We selected color scheme, no shadows, because that influences depth perception, and we wanted to see the extent to which stereopsis is contributing to good or how that performs with depth perception. We didn't have audio or vibrotactile feedback. In our study, we had 17 subjects in each condition. Had 4 tasks. One was a virtual training task, just to learn an interface. 2 were virtual experimental tasks, 10 minutes each, and we tested, and so that was kind of approximately a good time to take. And then we had 1 assembly of physical model. The point was not to test transfer of training, because we were not talking about training. We wanted to see if there were any aha moments. Copy the physical model in task 3 was the replica of virtual model from task 2, and task 2 was more complex than the first one. We had mini map for guidance, and total time was 60 minutes. So here's how assembly station looked. Everyone, regardless of the condition, immersive, non-immersive, was using and sitting in the same area. Data collection, we like to collect both objective and subjective data sets. Objective, undeniable results of your performance, but subjective helps you understand and situate that type of data and understand all those whys. Procedures, your typical procedure for conducting user study with informed consent starting, collecting baseline SSQ, and then doing training, tasks interspersed with another SSQ collection and collection of post-task questionnaire that we fine-tuned for needs of our study. So the results for objective data sets, we had obvious winner, immersive stereoscopic, provided highest number of assemblies. Interestingly enough, that in task 2, more complex, non-immersive, non-stereoscopic also had a maximum number of assemblies. Assembly time, again, in both tasks, immersive condition, stereoscopic condition was a winner. And there was significant difference in either task with 1 or 2 other conditions. And collisions, immersive, stereoscopic, created least of a collision. So perception of the depth was much, much better, I guess, than with other conditions. With subjective data set, we collected 272 reports. Only one person complained with severe symptom, and that person said that he experienced a lot of burping, severe burping. That was kind of our surprise because my student didn't notice any. And so you take whatever they say. But most frequent symptoms were oculomotor system from that group. Post-task questionnaires, a series of them, they had the IS condition had the most favorable ratings. And system usability scale, IS had the highest, highest rating. Behavioral responses, immersive people sway more, move more, nobody fell off the chair. People used only one hand. They could use 2, but they used only 1. And so in conclusion, IS was clearly more superior, but to us, a surprising result was non-immersive, non-stereoscopic condition performed fairly well. There were quite a few collisions, so that was not the winner. It was performed poorly. However, people managed to make those assemblies. And so we suspect that visual guidance that we provided with the highlights when parts would touch correctly in a zone, drop zone, we thought that was sufficient to guide somebody towards a successful assembly. And so for future work, we suggest and we plan to do more investigation on that condition. And of course, in parallel, compare it with immersive stereoscopic. And adding more visual parameters to strengthen the sense of depth, using more complex objects, and ultimate goal in training is you do training transfer studies. So learning something in VR, but bringing it to a real world domain. So this was conclude my presentation. Detailed accounts of research are in Yamashita thesis, freely available. Anyone interested in 3D models of our toy helicopters is available upon request. They were a huge hit with kids that visited our university, and they commented that VR assembly to them was much easier than physical one. I'm happy to answer any question that you may have. I mean, I ask next presenter to come and change a laptop.
Hi, I have a question. Nina Rosa from Utrecht University. You said the non-immersive, non-stereoscopic case.
Can you just come closer to the microphone?
The non-immersive, non-stereoscopic case performed very well. But would you argue that that is very different from, let's say, online tutorials that people could do or are doing at home already? Because it seems like a very simplified version of what VR could be. So like it could be a desktop thing that people are already doing. So I'm wondering what this further testing would include.
Further testing with non-immersive, non-stereoscopic?
Yes.
Oh yeah, sure. So you saw that we had large TV, 3D ready TV. Well, it's large. It doesn't fit in your gym bag, right? And so what we wanted to see if with the smaller screen, possibly laptop screen, could you still be good enough? Even with a desktop solution. So that would be definitely changing field of view would be one. And of course, you would like to go for more complex objects. We had toy helicopters. They had a decent number of parts, but you would like to increase that, so ramp it up. Our users were students at our university, and most of them did have a need to do assembly and maintenance. But this time we would like to bring it to actual training center and work with people who need to receive that type of training.
Okay, thank you.